Welcome to the first episode of all the modules in Python. So we are going to start off with the very first module alphabetically, which is ironically named ABC. We can use this module by using the import keyword and then typing ABC. Great. Okay. What does ABC do? So what ABC does is it lets you create abstract-based classes, which is a tool for frameworks, to create your own frameworks in Python. So let's start right now. And first, we use it to create an interface. So the way I would do that is let's make an interface called addable. If a class is addable, then it should subclass from this abstract base class, and it would need to implement dunder add. So what we would do is there's two ways to define this. We can either inherit from abc.abc like this, and this would work just fine, or we can use the meta class. We could type meta class equals and do abc.abc meta. So it's preferred to just inherit from abc.abc, but essentially what abc.abc does is it just is a class, an empty class that has the meta class equals abc.abc meta. So it's basically the same thing, but it's preferred to do this because it's easier to read. And now that we have this, we can start defining methods. So the first method you're going to want to implement is we'll probably implement the abstract method, and you can use this by using a decorator. The way decorators work is you put an @ symbol, and we're going to do abc.abstract method. And what this does, it will decorate our method and tell the interpreter that this method is abstract and must be implemented. And now we will type this up, and this should return it doesn't really matter, we don't have to put annotations. Okay, and you could just put an empty doc string that says add two things together. Sounds good, right? Okay, now that we have add implemented, it's all good to go. We don't have to implement anything else. And we can give an example where we have a class here. Let's just say we have an empty, we have a class C inheriting from addable, and it just is empty. We'll give it some docstring, and it's just empty. And we're going to run this. Okay, we're going to load up this file. Okay, so the problem with C is that it did not implement the necessary methods, and we could see this by trying to create an instance of it, and we get an error that you can't instantiate it with the abstract method add. The same thing would happen if you tried to do it with addable, because addable should not be instantiated. That's just how it works. Okay, sounds good. We are now going to fix up the C class. We are going to start implementing the required method, add. Okay, all you have to do is, you don't even have to do anything. It could just return a number. This isn't advised. Don't make a random class to do this, but this is just an example, okay? I'm not going to show you that it will work, because it will work. I'll guarantee you this will work. Okay, cool. We got that down. Okay, another thing to note, if you want to make an abstract property or an abstract class method or an abstract static method, you can put another decorator on top of it. So you can make this a property or a class method or whatever, but make sure that abc.abstract method is the closest it is to the method that's abstract. That's just how it works. Just trust me on that. We're going to get rid of that class for a second. And we are going to show another cool property of abstract based classes. So you can, if you don't want to specifically subclass, first of all, let's say we have a class C, and here, let's make a class C, and it already has the required method, so it's good. And we want to say that it implements this interface. We don't want to inherit from it. We just want to say that it implements it. So it could be a subclass, but we don't want it to inherit anything. So if this were to give us concrete methods, which it definitely could. So let's say if we had a concrete method add, which just delegated to dunder add, it would essentially anything that would inherit from it would get those concrete methods ready to use. But let's say we don't want those, and we just want to say that it implements the interface. For all practical purposes, it's a subclass. So what you can do is you can decorate this class with @addable.register, like this. And what this does is it registers this class as a virtual subclass of addable. So as instance checks would work, this would be true. I mean, not really, because it's not an instance. This would be true. Is subclass would work. So this would be true. But it wouldn't inherit anything. So it's not a real subclass. So in addable dot subclasses, C would not be listed there. Okay, cool. What if we want to say that instead of having to register a class, any class could be a virtual subclass as long as it implements it. Even if it doesn't say that it wants to be a virtual subclass, we want it to say that it's an instance of addable anyway. So let's say there's a class that came before we created addable. We would want to say that this class is a subclass of addable. The way we can do that is with a special method only for abstract-based classes. It must be decorated with the class method decorator, and it's called dunder subclass hook, like this. So the first argument should be class because it's a class method. The second argument can be, I'll call it other, okay? And when you're doing this, you want to be sure to do one thing, and that's you want to say, you want to make sure class is addable. The reason why I want to do that is if an abstract-based class can inherit from another abstract-based class and add more abstract methods. So if an abstract-based class would inherit from addable, we don't want it to have this subclass hook. So we want to make sure that class is addable, okay? Sounds good. And now we want to make sure that other has dunder add. The way we're going to do that is with the any built-in function, which checks if any of these checks an iterable and sees if anything is true in that iterable. So the way we're going to do this is we're going to say dunder add in quotes like this, a string dunder add in c.dict and for C in other.mro. Okay, it doesn't like that I'm using the variable C, so we'll call it maybe subclass, like this. Maybe it likes it better when I do that. So what the dict is it's a dictionary with all the methods, instance attributes, not instance attributes, class attributes. All the stuff are in this dict, in this dictionary. And what .mro means is the method resolution order. It's a little complicated, but just assume that this goes through the entire class hierarchy and checks if add is in anywhere in this entire class, if this class can use add. So we're going to use this, and if all this is true, then we're going to return true. Otherwise, it's a good idea to return not implemented. This lets the interpreter know to continue the regular subclass check, and this is what you should do. Okay, so I'm going to show how C is an instance of addable in just a moment. We're going to test this out. So we're going to exit for just a second, and we're going to load up this module back up. And I'm going to say is instance C from addable true. But C does not inherit from addable, and it does not have the addable.register decorator applied to it. And nevertheless, it's considered a subclass because of our subclass hook. So that's what subclass hook does. One last thing, a few more things. Okay, so first of all, we could get rid of this because we could just do that. And we're just going to show how we can have another abstract-based class inherit from another abstract-based class. And we're going to call this one commutative addable, and it's going to inherit from abc.abc as well as addable. So what this is going to do is going to only stuff that are commutative addables should be subclasses of this. That includes integers, complex numbers, floats, but not strings, because strings, it matters in which order you add it, right? Okay, good. So we already have the abstract add method, but if it's commutative, then you might as well make a reverse add method, which basically all it does is if it's the other way around. So if you implement rad in a custom class, user-defined class, and something is adding that to that class, and it doesn't implement add against that class can implement rad, which will add it the other way. It sounds a little confusing, but it's really simple. Usually, if it's commutative, you can just add it together like this. And because they definitely implemented add, they will get rad. So now this is useful because only if your class is commutative, all you have to do is say that you comply to this interface, this commutative addable interface, and you'll get rad. Pretty good. And yeah, that's all there is to it. Two more things. We have two other functions in the ABC library. So we have the get cache token function, and what this does is it will give you a number based on how many classes are registered as virtual subclasses. I don't know why this would be useful, but it's just something to know. I think it's usually 24 in the beginning, but yeah, if we register more classes, it'll go up by 1. I think that's how it works. And the other one is called update abstract methods, I think. And this takes in some sort of class or whatever, some class. Is this not a method? I was pretty sure this was a method. Or I'm pretty sure, called abc.updateAbstract method, abstract methods. And if you create methods at runtime, you can they won't, if you create abstract methods at runtime, they won't work unless you use this. So something useful to know. You probably won't ever need it, but that's it for this video. If you like this, then like it, and then also subscribe, because that'd be a really good idea. Okay, so see you.